So Troy, we're actually made the Bloomington Transit app. So we built a real Android transit app for Bloomington Transit. Our focus was not draw just bus on a map, but to solve the rider journey and the end to the end. So choosing the right trip and tracking the right bus line, and seeing the upcoming departures and then getting alerted before it is time to board on the exit. So everything is on a demo is driven by GTFS, Settle and a GTFS real-time data with the Google Maps used the visual layer. So what the case required? The brief asked for 5 core things. So working Bloomington Transit API integration and automatic pulling and accurate arrival times and an individual bus tracking and a schedule table on an interactive route map. So we did all of these, but we also framed the rider problem around the 3 questions. So what should I take, and then where is my bus, and when should I act? So that rider framing is what the push us to go beyond the basic visualization demo. So this is how we implement it. So technically, and the app is organized around the right separation of concerns. Static GTFS gives us a route shape and a stop order, and then service dates rows, and fallback schedules. GTFS real time give us a live vehicle and then live trip updates. So on the top of that, the Android UI stays through the repositories and then view models. The architectures made it possible to extend the system with the planning and returning, and then push delivery without rewriting the main app.
My name is Divya, and this is the core required flow. A user starts the route list, opens a specific route, sees the route polyline and also the stop makers on the route. Then they will see the live buses that are going on top of the route. The user can tap a live vehicle to track a specific bus, and the schedule area adapts between the route level and the stop level departures. That makes the route screen useful for a rider in that moment, not just visually impressive. This is where we move beyond the minimum brief. We added a real trip planner so riders can choose the right option, not just inspect a route. Then we connected planning to action timing to giving them alerts. In the app, the rider gets boarding and destination alerts based on stop sequences, and also the GPS aware boarding detection. And as an extra technical extension, we built a backend push alert service with Firebase cloud messaging and also Firestore. So the same alert model can work even when the app is not actively open. So our final message is simple. We satisfied the full required scope: API integration, live polling, ETAs, selected bus tracking, route maps, and also a schedule table. On top of that, we layered in the features that make the project more competitive: trip planning, transfer support, in-app boarding, decision alerts, a back-end push alert service, and even an architecture that is clean enough to explain and expand. This is not just a prototype map, it's a transition tool for all riders. Thank you.